Recording in progress.
Okay, we're discussing the fiber deployment for etheric networks on the RDOF. So first of all, we have this document, Fiber Design Update, September 8th, where we've gone through and looked at the total households per county, the trunk lines to move bandwidth through the counties, provisioning at a minimum of 10 megs per household. We achieved these numbers, 38 gigs of capacity for Alameda, so forth and so on. Where you see blanks, it's a summary of the trunk line based south in this case. And that ultimately leads us to these estimations of how many 400 gig waves you would need at max build out. Then we postulate, okay, let's go to 20 megs per household. So this is for, headroom and growth. And in addition to doubling the bandwidth provisioning, we then double it again for ineligible locations or businesses that might want to add to our service. And then just to look at absolutely crazy load planning, we look at 100 megs provisioning per household, assuming we have a vast amount of growth that we have to accommodate later. So it sort of gives us a range. Also, we can look at the total county planning, which we have here in our fiber proofs. And here we show at 10 megs per user at peak, what sort of capacity we would have if we obtained something like a 10% market share overall. This take rate is too low for the FCC requirements, but with the general take rates, the capacities are certainly quite adequate. So this gives us another guideline, and this guideline here doesn't really impact negatively the forecast we have elsewhere. Here in San Benito County, where we anticipate achieving 21,000 customers, we see less than one single 400 gig wave. So we can take these numbers and add them to the other sheet, which I will do now. Looking at these aspirational numbers for market share by county, because we have to be viable, you have to have market share. In this final column, we're provisioning at 10 megs per residential and 20 megs per business. We have this column here that's created. The theoretical maximum capacity requirements we would need. This ends up being about 3.5 terabits. At the 100 megs per household model, it's 6.4 terabits. At the 20 megs per household times 2 for non-eligible is 3.7 terabits. And 10 megs per household, 649 gigabits. So analyzing these numbers, what we come up with is analyzing these numbers, we basically see that in most parts of the network outside of the Bay Area, we're not going to need more than 1 or 2 400 gigabit waves. So as described here, our approach is to tend towards dark fiber where possible. By overlaying a passive system over an active system, we can put buildings on net that if they lose power will not bring down the whole system. So we want to have a amplified and a non-amplified backbone. Solid Optics has done a good job of supporting our initiative to integrate with Arista. So rather than using a classical optical network for this network, and I think for many operators moving forward, we're going to be looking at more of an optical electrical network, meaning using routers to handle and manage the waves rather than using a completely separate system like an ADVA. So we partly think this is a good idea because of Arista's extensible operating system and CloudVision, which are going to provide a lot of support for this. So we have described this Arista system. Well, we've offered you this unlisted tutorial that goes through just why this is so awesome. And it really is an extraordinary piece of engineering in terms of the pricing we're getting on it. And this bill of materials here describes both the lightweight system, the 7020, where we have two 100 gig channels, an east and a west, and then we can aggregate a bunch of 10 gig channels. We have 24 of those. So for light routes or beginning routes, we can use these 7020s. And for places where we need 400 gig optics, we use a 7280. And this particular 7280 can support encryption at line rate of the network, which is interesting as well. So those are the two basic systems that we're looking at for providing the fiber backbone. The lighter weight 7020 and the heavier weight 7280. This provides a listing of various types of optics. So if you begin with a 2x100 7020 SR, you can put 100 gig 1310 80 kilometer optic on it if you like, and directly connect point to point using 100 gig optics. This is the EDFA-MUX, which is an amplified MUX that will support 8 100 gig channels over 80 kilometers, and then allow an overlay of passive optics for adding more splice points later for future proofing. So at this point, what we're looking at is passive DWDM on channel 17 to 27 in the ITU-C grid. And then we can amplify the 28 to 35 channels if we drop an EDFA-MUX later. And we can amplify the channels 29 to 45 if we use the Arista 8x400 system. And obviously that is more than 8 channels. So you can put in 2 or 3 of these. You need quite a large Arista and you need a lot of demand. So the system is fully scalable. The question is, what sort of questions are people going to have about this system? So next, we describe the topology. So what we have here is the Lumen or level 3 network from Soledad going down to Los Angeles over Santa Barbara. That's one area where we use the level 3 network. The level 3 along the Highway 36 coming out to Eureka, the level 3 coming from the Central Valley above Clear Lake, and then level 3 has a path that we're going to use from Santa Rosa to the coast. In this case, this is Manchester and Point Arenas. We are working with Sonic to access AT&T, which is going to be at Laytonville, hopefully Garberville, Fort Bragg, and the municipality of Mendocino proper. And this path is an AT&T path, and we wish to collaborate with others to overbuild this path, since AT&T does not want to lease dark fiber. So it's in the state's interest, in the public's interest, that a more open and competitive type of provider be available on the Highway 101 on the critical route from Ukiah to Eureka. And we are providing KMLs with the overlay of each of the vendors, and we have trimmed back a great deal of secondary routes. Here in the, let's see, look at it. In another fashion, of course, we can go carrier by carrier, layer by layer. So the core of the network is a fiber ring around the Bay Area using the Zayo network. We've also subleased that out to Salinas and Monterey, and then we have subleased or are in the process of subleasing dark fiber from Santa Cruz to Soledad, which was a Sunesis project, which is now owned by Crown Castle. So we should have extensive capacity there. And then we have two scenarios for the Central Valley, effectively. We have the level 3 network that we can use to get from Highway 36 Red Bluff and provide connectivity into our support area, which is in Glenn County, and then have that terminate ultimately here in the greater Sacramento area. This is the hub that would essentially manage splitting traffic either to the west or to the north. And it might be easier for the moment to look at this without the background. So this other path to the east of the level 3 path that we described here is all Zayo. So the advantage of Zayo is that they will be providing us with definitely dark fiber on this whole route. And as a result, we will probably want to carry most of the backbone traffic along this route on the eastern side of the Central Valley to Sacramento, rather than the level 3 route. But we could live with either route. But we believe that level 3 will probably give us the best pricing if we use their backbone. So we'll have to take a look at how they're handling that. And we are going to be going through Tilson, who is going to help us with construction of the network, to discuss this with level 3, as they have a very good relation. Now, what we see up here is for failover purposes of the north. So we will turn on the background now. So Etheric has support on the Oregon border here in Hornbrook. So we need, in case of a fiber cut to the south, to be able to fail over. We want to fail over to Eugene. This will also help with the support that we received in the Shasta and Tehama area, but really the Shasta area. And to look at that over here, you can see this is the support areas where we need the support. So if there was a fiber cut here, we need to fail over. And it appears that a 100 gig wave would be quite adequate for failover from the California-Oregon border to Eugene. And the only question will be whether we have to deploy our own devices into the regenerator ILAs, or whether we just lease the waves directly and don't have to worry about the underlying mechanics. So I think that fairly adequately describes the network in the Humboldt, Trinity, Mendocino area. It adequately describes the network going to Oregon and through the Central Valley. This then brings us to the Inyo-Mano area we receive support in. And the method we wish to use for that is Zayo has a wave service from Sacramento to Reno through Plumas County, which is where we have support. So although they would prefer us to lease their direct path on Highway 80, we have no support there. So this will be quite useful to use the Plumas route to connect to Reno, which is a hub for Zayo, and then use the I-395 fiber, which probably had some money that was public put into it, to get access to the ILAs where we have support in the Inyo and Mono County areas. And this fiber ultimately terminates in Barstow. Additionally, we will be leasing fiber from Zayo to get into Death Valley from Las Vegas. And there's one point at Pahrump, and we believe we can find another splice point here. So this is probably going to be one of the last parts that we get to of the network, because so little use and so much difficulty, but you never know. Sometimes remote areas end up being quite quick to construct, and problems in getting things built can fall into regulatory and community and to vendor resistance. So it's very difficult to predict with 100% certainty which will be the last part, but certainly to lease fiber to serve this small amount of support, 516 locations in this case, will be interesting. But it will allow us to create a fixed wireless backbone from the I-395 to fiber in Nevada, so that if either side cuts, we maintain service. And then we would lease a wave from Las Vegas to Barstow to give true fiber failover to the I-395 route. And then additionally, a wave from Barstow to One Wilshire in Los Angeles, where we will maintain a data center and peering. And then the Lumen Level 3 network going from Los Angeles through Santa Barbara and up the coast. So that really provides the macro level view of the fiber. As long as we have access to dark fiber, there's not going to be any issue with supplying the demands of this network. There shouldn't be any issues with just leasing waves in these very remote areas where there's little competition and we may get pushback from the tier 1 incumbents. And here in the Bay Area, we have an extensive network plan. So getting into the Bay Area network and contrasting it to our support, Zayo has considerably more fiber than this, but what we're looking at for the time being, and these are our RDOF areas, including this orange area here, which got highlit for some reason or another. This provides fiber within 10 to 20 miles of all of our underserved locations, which is what we need. And additionally, in phase 3, we will be adding some fiber here and there on this network. But we have a ring now that we'll be leasing from Zayo that goes around Contra Costa County, Alameda County, dealing with Extenet to get fiber into these rural areas of San Mateo County, Crown Castle and Extenet, coming around the Highway 1 area, very underserved area. And we'll have to do a small amount of construction here. So this is not required to support the RDOF, but if we can make it viable, we think it's a good community service to ensure that fiber is done in rings and multiple operators can access it. So there is a small gap that will cost a few $100,000 to complete here, and possibly the same in the mountains. And all of this will be in the fiber KML. So that is essentially what we've developed for the fiber network to support this project. Thank you.